Hi guys, hope everyone is doing good, and this is CoddyMaddy here with another video on AMCAT Automata series. So in this video, I'm going to discuss about some of the diagonal elements in the matrix, so how the sum is performed. So initially we discussed about how to get the matrix input and how to store it as an array. So in this video, we're going to perform the sum, so let's get started. So before getting started, if you think my work is good, please don't forget to like, share and subscribe to my channel. Keep supporting guys. So in today's video, we're going to discuss how to perform the sum of the diagonal elements in the matrix. So let's get into the program. So this is the coding problem. The function matrixsum int m and int n is supposed to return the sum of the diagonal elements of the input array matrix having m rows and n columns. Complete the function method matrixsum int m int n to get the desired output. So this is how a program question in an AMCAT automata is displayed. So we have to understand the question and we have to analyze each and every statement that is displayed in the problem, and we have to derive our requirements. So this is how the question is displayed along with the sample input and the basic structure of the program. If you see, the function matrixsum int m int n is supposed to return the sum of the diagonal elements. So let us think of a matrix. So a matrix can be either rectangular or squares. Just think about the rectangular matrix. Does it have a diagonal element, or does square matrix have a diagonal element? Yes, obviously it is square matrix, because square matrix will have equal number of rows and columns, and hence it makes a square structure, and obviously you are getting a diagonal element in that. But in the case of rectangular matrix, a proper diagonal is not at all formed. So the diagonal elements means obviously it infers that we are going to use a square matrix here, and which implies m is equal to n, equal number of rows and equal number of columns of the input array matrix having m rows and n columns. So this is what we have derived from the statement 1. Complete the function matrixsum int m and int n to get the desired output. So just see the problem and analyze it. So first line is #include stdio.h, which is a common header file that we are going to include in all the programs. So next line, #define size 100. So they have defined the maximum size as 100. So it should not exceed more than 100. So the maximum size of the row or the maximum value of the column should not exceed more than 100. That is what is defined from that line. Then int matrixsum, int row and int col. So they have made some function definition, and that function name is matrixsum. So that matrixsum has two parameters or two arguments or two inputs. One is int row and another is int col. Row is going to denote the number of rows and column is going to denote the number of columns. And if you see, before the matrixsum we have int, which means it's going to return an integer value. So next we have a code and code here. So we have to code whatever we wanted to code there. And next, after the function method, we have int main. So in this int main we have two variables. One is m and another one is n. So they're using it for storing the number of rows and the number of columns. So as you see, the next line, scan of %d, ampersand m and ampersand n. So which means the value of m and n is stored. So what value can be actually got? It should be obviously the rows and the columns. Okay, so next on the next line is the function call. Printf %d, matrixsum m, n. So if you see, the value of m and value of n is passed as parameters, which means the m is going to store the value of rows and n is going to store the value of columns, which actually corresponds to row and called in the function call. If you see, the value of m will go as the first parameter in the function, and the value of n, which is a column value, will also go as a second parameter to the matrixsum function, and this function is actually returning an integer value. If you see, int matrixsum int row int col, so it is going to return a value, and that returned value is displayed here. So we are going to return a value, and that value should be obviously the sum of the diagonal elements of the matrix. So now let us take an example. If you see, this is a square matrix. Here the number of rows is 4 and number of columns is also 4. So we can say it is a square matrix. And here the diagonal elements are 9, 11, 4 and 10. because they are the diagonal elements that lie in the middle of the square values 9, 11, 4 and 10. And here the sum of the diagonal elements is 9 plus 11 plus 4 plus 10, which is equal to 34. So only a square matrix can have diagonal elements, so the number of rows and columns will be same and the diagonal element sum is to be determined. So here the sum of the diagonal elements is 34. So now this logic is to be applied in our problem, especially in our function call. Now please pause the video once and try to write the logic, and then we will discuss the logic. So hope you guys got the logic. So the first step in our program is we are getting the number of rows and number of columns in the matrix. So that is very important. So we are getting it as we saw in the question. We are getting it and storing in the value m and n. So that is the first step in our logic. And then what they are doing is they are calling the function in the program. So obviously this means the elements of the matrix should be got in the function, because if you see, after getting the value scan of percentage d comma ampersand m comma ampersand n, they have given a printf, and within that printf we have a function call. So now the function is being called along with the number of rows and columns. So in this function what we have to do is, first we have to get the elements of the matrix. What are the values that are held in the matrix? So we have to use a for loop for the row and for loop for a column, as we have already discussed, and we have to get all the elements of the matrix. So once that elements are being obtained, we have to perform the addition in the diagonal elements. So how to identify the diagonal elements is the main concept here. If you see, I have displayed an imaginary matrix here. You see A11, A12, A13, all the placeholders, and it can hold any value there. But if you see, A11 means the first number denotes the I, that is a looping variable I, which is corresponding to the row loop, and the second number will correspond to the column number. If you see, A11 means it is displaying the element at one first row, first column. A12 is first row, second column value, and A13 is first row, third column value. Similarly, A21 is second row's first column value, A22 is second row, second column value, A23 is second row's third column value. Similarly for the third row also. So this is how a square matrix is represented basically. If you see, if you identify the diagonal elements A11, A22 and A33, they hold the same values for both row and column. In such a case only they form the diagonal. If you see, the diagonal is formed by the middle slanting values, right? So A11, A22, A33. So if you see, when I is equal to j, like when the row value is equal to column value, we have to add that value. Else we have to ignore other values. We have to ignore because we have to perform the sum of only the diagonal elements. So if you are in A12 or if you are in the A13 value, we should not consider it for the addition. Instead, if you are in A11 or if you are in the A22 value or if you are in the A33 value, then we have to add them. So here we are going to use two loops, as I said before. One is for outer loop for the rows. We are going to use I as the looping variable, as we have discussed already. And loop 2 is for the columns, and that is the inner loop within the row loop, and j is going to be used as a looping variable again. So the condition is, if I is equal to j, when the row value is equal to column value, we have to perform the addition, or else we have to ignore it. And then the last step is we have to display the result. So this is a basic logic for performing the sum of the diagonal elements. So let's see how it can be done. So this is the coding problem that we saw. So first we will create the variables that we required, and sum is equal to 0. So I and j is obviously the looping variables, and sum is going to hold the sum of the diagonal elements. So I am initiating it to 0 for a safer side. Then I am creating a matrix of 100, 100. As we saw, the maximum size of matrix was 100. Hash defines size 100. They have mentioned it on the preprocessor, below the preprocessor directives. So the maximum size the matrix can hold is 100 cross 100. So we have created a matrix of that size. Now we have to get the elements of the matrix. for I is equal to 0, I less than row, I plus plus. Within that, I am creating a inner loop for the columns. I am storing the value. Scanf percentage D, comma, ampersand, matrix of that particular row and that particular column. So this is how we get the values for the matrix. We have discussed this before itself. Please do watch that video if you have forgotten to. And after this, we have to perform the sum of the diagonal elements. For that, again, we have to access each and every element. So again, we will create and start a loop for I is equal to 0, I less than row, I plus plus. And again, for j is equal to 0, j less than call, j plus plus, if I is equal to j. We have we have seen this condition. So when the value of I is equal to j, we have to perform the sum. We have to add it to the sum variable. Sum is equal to sum of that particular value, matrix of ij. So now I have closed it. So first what we are doing is, we got all the elements of the matrix and we have stored it in the mat variable, mat array, and after that again we are accessing each and every element and we are checking whether I is equal to j. If that is the case, we are adding it to the sum, and after this we have to return a value. If you see, this matrix sum returns an integer value. So obviously, you are going to return the sum value. So once the sum value is returned, it will be displayed here in the printf. I am saving this program and I am running it, giving 2 number of rows and 2 number of columns, 3, 5, 7 and 9 as the input values, and have got the output as 12. Sum of the diagonal elements as 12 because 3 plus 9 is equal to 12. So we got the output as 12. So hope you guys like this video. If you have liked this video, please don't forget to like, share and subscribe to my channel. Keep supporting.